Hello guys, welcome back to Conceptual Math by NS, where concepts in math comes to life. This is another session, part 2 on CSEC matrices, where we will be focusing on addition and subtraction of matrices. Remember guys, making excuses will never get you anywhere by NS. So let us get into this part 2 session on matrices. So addition and subtraction of matrices. So let's look at the key points that you need to remember about addition and subtraction of matrices. So the first thing here is that two or more matrices can be added or subtracted if they are of the same size or order. Now guys, remember in part 1, we look at the size or the order of a matrix. That information is very key, which is why we looked at it initially. So for two or more matrices to be added or subtracted, they must be of the same size or order. So that means you cannot add or subtract two matrices that have different sizes or different orders. That cannot work. You have to add or subtract matrices that are of the same size, right? So if they are of the same size or order, it means that they are compatible. And once they are compatible, it means that we can add or subtract them. So in other words, I can add a 2 by 2 matrix with another 2 by 2 matrix, right? I can add a 2 by 1 matrix with another 2 by 1 matrix. However, I cannot add a 2 by 2 and a 2 by 1 matrix, right? This cannot work. I cannot add these two because they are of two different sizes. One is a 2 by 2 and one is a 2 by 1. However, I can add or subtract a 2 by 2 plus another 2 by 2 matrix. So these two matrices here are of the same size or order, so I can add or subtract them. Okay, guys, that is the key. These over here, a 2 by 2 and a 2 by 1, we cannot add them, right? Because they are of two different sizes. And as a result of that, we cannot add or subtract two matrices that are of different sizes or order. So it therefore means that a 3 by 2 matrix can be added or subtracted to another 3 by 2 matrix. This is compatible, guys, right? So when we're talking about addition and subtraction of matrices, the matrix themselves that you are going to add or subtract, first and foremost, must be matrix that are of the same sizes or order, right? That means the number of rows and columns in these matrices must be the same. So if you notice here, right, this matrix has 3 rows and this other one over here has 3 rows, as well as this one has 2 columns and this one has 2 columns. So it means that they're compatible. They have the same size or order, so we can add them, right? And just like this one up here, this is a 2 by 2 and this is a 2 by 2. So it means that these two matrices are compatible. They have the same number of rows, right? And they also have the same number of columns. And down here, they have the same number of rows, 3 rows, and the same number of columns, 2 columns. So these two here would be compatible. However, a 2 by 2 and a 2 by 1 matrix, these would not be compatible, because they are two different sizes or order. So guys, remember, this is conceptual math. And with conceptual maths is where the concepts comes to life. Okay, guys? So let's move to the next point. To add or subtract matrices, you must add or subtract corresponding elements only. So now that we have established that to add or subtract matrices, they must be of the same sizes or orders. That means the number of columns in matrix 1 must be the same as the number of columns in matrix, the number of rows in matrix 1 must be the same as the number of rows in matrix 2, and the number of columns in matrix 1 must also be the same as the number of columns in matrix 2. With that, guys, it means that they would be compatible and we can add or subtract them. Now that we have established that, the next thing that we need to do is to add the matrix, right? Is to add them. Now, to add them, we must add or subtract corresponding elements. Now, what do we mean by corresponding elements, right? It is saying that we're going to add or subtract those elements that are in the same position. So if you remember in part 1, we looked at identifying the position of the elements in a matrix, right? We look at identifying the elements, the position of elements in a matrix. So let's just look at this quickly here. So in this matrix here, AB, the element A would be in the first row, first column. In this other matrix here, matrix C, this matrix over here, sorry, C, the element C would be in the first row and first column. So it therefore means that this element in matrix 1, which is A, and this element in matrix 2, which is C, are in the same position. It means that they correspond. So it means that element A and element C would correspond. And so we call them corresponding elements. Okay, guys? And it therefore means that element B in matrix 1 would correspond to element D in matrix 2. So it therefore means that element B and D are corresponding elements. Right, guys? And so when we're adding or subtracting matrices, we must add or subtract the elements that correspond. That means the elements that are in the same position in both matrix. Okay, guys? So let us look at our third point here now. So here's an example. So if we have matrix A, which is that, and matrix B, which is E, F, G, H, and matrix C, which is P, Q, M, N, then what would be the sum of matrix A and B? That is what this is asking us for. What would be the sum of matrix A and B? That is A plus B. So guys, remember, what are the concepts? Here are the concepts up here. So are these matrices here, do they have the same order? Yes. This one is a 2 by 2. This one B is also a 2 by 2. And this one C is also a 2 by 2. So it therefore means that these matrices here would be compatible if we were to add or subtract them, because they are of the same size or order. So yes, we can go ahead and add them. And now that we have established that they are compatible to be added, then to add them, we must go ahead and add or subtract corresponding elements. So guys, we're doing both addition and subtraction. Addition and subtraction of matrices follows the same rule, right? In terms of compatibility and in terms of the elements which correspond. So you will hear me say add or subtract because it follows the same principle. However, when you're to add, you add, and when you're to subtract, you subtract. That's where the difference will come in. Okay, guys? But they follow the same concept in terms of compatibility and in terms of performing the operation on corresponding elements. So now, let us look at part 1 in this example here, where we're to add A and B. So guys, follow the example carefully. Follow this example in red here. I'm highlighting in red. Follow it very carefully. So here, this is how you set it out now, guys. So when you're setting out the problem, this is how you set it out. So A plus B equal, right? And we substitute matrix A, right? Because A comes first, so we replace A with the matrix A, right? Which is A, B, C, D, plus, so we put our plus sign, plus B, right? And we replace B with the matrix B, which is E, F, G, H, right? Both of them are 2 by 2 matrix. So now, let us add now. So the last step over here, guys, is showing us the adding process. So to add, it means that we're going to add A plus E. So follow this carefully, guys. So it is A plus E. So what do we have over here? A plus E, right? Now, because these are algebra, we can't go any further. So we will just leave it as A plus E, right? These are letters. We can't simplify them any further. So A plus E is A plus E, right? So that's how you perform the operation, guys, okay? And B correspond with F. So it therefore means we will add B plus F, right, guys? And that is how we'll get the result for the new matrix over here, B plus F. And C, so we will add element C with G, right? So that's how we will get C plus G over here. And we go ahead and we add D plus H, and that is how we get the corresponding result over here in our answer. Okay, guys, so that is how you add matrices, guys. They must be of the same size or order, and having established that, you go ahead and you add corresponding elements. So let us look at subtraction now. It's the same process. The only difference is that we're now subtracting. So A subtract B means that we replace the matrix A with the actual matrix, which is A, B, C, D, subtract, put back our subtraction sign, and replace the matrix B with the actual matrix, which is E, F, G, H, right there, right? And so now we're going to perform the subtraction now. So to perform the subtraction, and guys, you can include all the steps, right? You can include all the steps. And so to subtract now, we place element A, which corresponds with E, into our new bracket over here. So it means that it would be A subtract E, right? So A subtract E. Whatever that turns out to be, we put that right here. And now we move to the next element, which is B subtract F. So B subtract F gives us B subtract F. And whatever that result is, we would put it right here in our answer. And we move to C subtract G, right? And so that comes right here, C subtract G. And the last element that we are to subtract is D take H. So that would give us D take H right there. And so, guys, that is how we add our subtract matrices. We add our subtract corresponding elements. Now, for those persons who will have challenges doing this, what I will advise is that you do rough work. So what you can do is do rough work. So remember now, we are adding or subtracting corresponding elements. So if the elements are numbers, the rules pertaining to directed numbers, guys, that is negative and positive numbers, the rules pertaining to directed numbers, to adding and subtracting directed numbers would apply here, right? So for those persons who would want to see a further breakdown as to how we are actually adding or subtracting the elements would be this. So let's take back, for example, example 1 here, which is A plus B. So we established that we are to add corresponding elements. So that means we would add element A with element E. So if you want to show that rough, guys, what you're actually doing is saying A and the plus sign that is between the two matrices would come between there, and then you put your last element E, right? That is what you're doing. You're actually, so the plus sign that is between the two matrices, guys, you're always putting it back between the two elements when you're adding or subtracting, right? So the plus or the minus sign that is between the matrices, whenever you're adding or subtracting the elements, you're always putting back that sign between the two corresponding elements that you're adding or subtracting. And that is what is shown exactly over here. When we go to an example where we have numbers, I will demonstrate that to you even clearer. Okay, guys? Now, we're not going to talk about the properties, the commutative and the associative property of matrices just yet. We're going to come back to that. We are focusing now on the principle of adding or subtracting the matrices, right? And the principle is that the matrices that you're adding or subtracting must be of the same size or order, right? So a 2 by 2 can be added to another 2 by 2, okay? We cannot add a 2 by 2 with a 2 by 1 or a 2 by 3, right? These would be a no-no, right? However, these can work because they are of the same size or order, so we can add or subtract them, right? And having established that, you then move ahead to add or subtract the corresponding elements now. Okay, guys? So let us move to some worked examples now, where we have numbers. Now, guys, this is a little activity which we're going to carry out here. Now, let me just do a little refresher of the rules pertaining to adding and subtracting directed numbers. So, guys, these are the things you need to remember when you're adding or subtracting negative or positive numbers, right? So, you must recall the sign reduction rule, that if you have a plus or a minus sign beside each other, you will reduce this to a subtraction sign, right? So if you're adding or subtracting two numbers, guys, and there's a plus and a minus beside each other, right? Between the two numbers, there's a plus or a minus. Between the two numbers are a minus or a plus. So it could be a minus or a plus or a plus or a minus. Same difference, right? It would reduce to a minus, right? And the next one is if we have two negative signs beside each other, we would reduce it to a plus. So that's something you need to remember, guys, when you're adding or subtracting negative and positive numbers. So if you have a plus or a minus beside each other between two numbers, right, you reduce that to an overall subtraction sign. And if you have two negative signs beside each other, you would reduce those two signs between two numbers to a plus. Okay, guys? So please bear that in mind. Now, having established that, the next thing you need to know, and I'm going to use letters to demonstrate it. If you have negative A plus B, right? What should you do when you see the problem set out like this? So if you have a number A, negative A, and a number B in this fashion, what should you do? Should you add the numbers or should you subtract them? Well, we're going to get to that, guys. Or if it is positive A, take B, what should you do? Now, for these two, anytime you're adding or subtracting numbers, guys, and you see this format, you see this outline, what you must do with those two numbers, A and B, right? Those are letters representing numbers, right? What you should do with those two numbers is to subtract and keep the sign of the bigger absolute value. So you notice that you will subtract because the signs are different. The signs are different. You have a negative and a positive. You have a positive and a negative. So anytime the problem looks like this, guys, right? Whenever you're adding or subtracting numbers and they occur like this, where you have a plus or a minus sign, it means that you're to subtract and keep the sign of the bigger absolute value, right? So when the signs are different, you subtract, keep the sign of the bigger absolute value, right? Versus where you have, for example, negative A, take B, or positive A, right, plus B, right? So when it looks like this now, right, this is where now you will add and keep the sign. So you notice that in these problems down here, right, the signs are the same. So you have two negative signs and you have two positive signs. So whenever the signs are the same, when you're adding and subtracting, guys, remember, don't mix up addition and subtraction now with multiplication and division, right? We're talking about addition and subtraction. There is no multiplication or division sign here, guys. This is strictly addition or subtraction. And anytime you're adding two numbers or subtracting two numbers, when you're looking at directed numbers, right? This is how it will appear. It will always look like this, guys. It will always look like this, right? And so when it looks like this, I am telling you, this is what you're to do. So you will have a case where one of the sign, let us go back up here, one of the sign will be a negative and one will be a positive. So in a case like this, you must subtract, keep the sign of the bigger absolute value. In a case where one is positive, one is negative, same procedure, subtract, keep the sign of the bigger absolute value. So whenever you're adding or subtracting directed numbers, you must only subtract when the signs are different with the two numbers. So when the signs are different with the two numbers, you subtract, keep the sign of the bigger absolute value. However, when you're adding or subtracting directed numbers, guys, and the signs are the same between the two numbers, when the signs are the same between the two numbers, you must add them and keep the sign, because you can only keep the sign if the signs are the same. If the signs are different, addition wouldn't work, because addition goes with keeping the sign, and you can only keep something that is the same, right? Subtraction goes with keep the sign of the bigger absolute value. So anytime you subtract, what should follow is keep the sign of the bigger absolute value. And when you say you're going to add the numbers, what should follow in terms of the sign is to keep the sign. So addition goes with keeping the sign, and subtracting the numbers goes with keeping the sign of the bigger absolute value. Okay, guys? So down here, because the signs are the same, negative A, subtract B, it means that you would add both numbers, guys, add both numbers. So if this was a 2 and this was a 3, you add them and get 5, and you keep the sign, it will be a negative 5, right? If you have positive 2 plus positive 3, you would add the numbers 2 and 5, and because it's a positive and a positive, you get a positive 5. Okay, guys? Please bear that in mind. So let us now look at these examples, guys. So here's a work example. So given that A is that, B is that, and C is that, right? What is A plus B? So here's it demonstrated here. So A plus B, therefore A plus B is equal to, so replace A with the matrix 4, negative 3, plus, right? Put back our plus sign there. And then we go to 2, then we insert matrix B, which is 2, 5, right? And now, guys, are these two matrices compatible? Yes, right? This one is a 2 by 1, right? And B is also a 2 by 1. So it means that they're compatible. We can add them, right? And now that we realize that they're compatible, we should go ahead and add corresponding elements. So 4 in matrix A corresponds to 2 in matrix B, and negative 3 corresponds to 5 in matrix B. So that is how we're going to add. And what is between the two matrices? We have a addition sign. So it means that we're going to add the elements. Right, guys? So let us move now to this step here now. So this step is showing how we're adding the elements. So it's 4 plus 2, right? And everybody knows that 4 plus 2 is 6, right? So we add and keep the sign here. So that's a what? That's a plus 4 and a plus 2. We know that we don't have to put the plus beside the in front of the 4, guys, because when a number is positive, we don't have to put the plus there, right? But we know it can be written as plus 4 or 4, right? So according to what I said before, signs are the same, add and keep the sign. So that's how we get our positive 6 here. And then we move now to negative 3 plus 5, right, guys? Remember, the signs are different now. It's a negative 3 and a positive 5, so we must subtract. and keep the sign of the bigger absolute value. So we take 3 from 5. Everybody knows that 3 from 5 is 2. And in terms of the sign now, because we are keeping the sign of the bigger absolute value, the bigger absolute value here is 5, and the sign that is in front of 5 is a plus. So that is how our answer becomes a positive 2 down here. So guys, the sum of A plus B is 6, 2. So that's your answer, the matrix 6, 2. Okay, guys, I hope we're clear on that. I'm trying to make it as simple as possible. All right, so let us move now to example B, guys. We're still adding, so it's another opportunity for you to follow again. So here we're adding matrix B plus A. Before we were adding A plus B, now we're adding B plus A. So we substitute matrix B, which is 2, 5, right? That's matrix B. And then we're adding that to matrix A, which is 4, negative 3. So now remember, guys, we are going to add corresponding elements, and the element 2 in matrix B correspond to 4 in matrix A, and the element 5 corresponds to negative 3 in the matrix A. So we're going to go ahead and add now. So in our next step over here, we are showing that we're adding. So we take the element 2 and put our plus symbol that is between the two matrix here, plus 4, right? And then we move to the other element. So that's 5 plus, right, negative 3. So we set out the elements exactly how we are to set them out based on what we're following here, right? So it's 5, put our 5, plus, the plus is between there, so we put our plus, and the negative 3, we put our negative 3. So now it is time now for us now to carry out this calculation. So 2 plus 5, guys, again, go back to what we did previously. So that is 2 plus 4, signs are the same, right? So it means that we're going to add and keep the sign. So if we add and keep the sign, guys, we're going to get 2 and 4 is 6, and the sign is positive, so we get positive 6, right? And so the next one now is 5 plus negative 3. Now, guys, you would recall that I said that if you are adding or subtracting and you have two signs beside each other in between two numbers, we must reduce the sign, right? Because we have two conflicting signs here. So we need to know what we're to do, right? We can't perform addition and subtraction at the same time. So we need one sign between there to tell us to break it down, to tell us whether it should be a plus or a minus, right? But we need one sign. So we will reduce this to a subtraction sign. So it is now 5 take 3. Okay, guys? And so we know that the signs are different, right? It's a plus 5 and a negative 3. So we must subtract and keep the sign of the big absolute value. So when we take 3 from 5, we get 2. And because 5 is the bigger value, and it has a plus sign before it, our answer is now plus 2, which is 2, right, guys? So we end up with 6, 2. So that's basically how we go about adding matrices, guys. Now let us move to example C. That is where now we're subtracting now. So here we are subtracting. So the question is A subtract B, or A take B, right? So A take B, so let us set it out now. So this is how you show your working, guys. This is how you show your working. So A take B equal to 4, negative 3. So that's matrix A subtract matrix B, which is 2, 5. And in this step here now, we're going to show what we're doing. We're going to show how we set out the subtraction of these elements in these two matrix. So now, so 4 and 2 correspond. So it's going to be 4 subtract 2, right? So remember, we in setting it out, guys, we put the operation between the two matrices between the elements in this step, right? We're showing everything so we don't make any mistakes, right? Remember, this is conceptual maths where we're showing you the breakdown, the simple way to do this, guys, right? So now we have negative 3 take 5. So we set it out as negative 3 take 5. And now that we set it out, we're now going to perform the operation. So let me clear. So remember we're here, guys. Okay, so let us do the top operation. So it is 4 take 2. So remember, guys, the 4 is a positive 4. So once you see a plus and a minus sign when you're adding and subtracting, guys, no multiplication sign is here, no division sign is here. So do not mix this up, guys, with multiplication and division. We're talking about addition and subtraction. So we notice that we have 2 different signs, so we must subtract. Once the signs are different, guys, we subtract. Once the signs are the same, we add. So here we will subtract. So 2 from 4 is 2, right? So we subtract, keep the sign at the bigger, and because the bigger number is a positive 4, so its answer must be a positive 2. So that's how we get this 2 here, guys. That's how we get this positive 2. Let's now go on to the other operation down here. So it is negative 3, right? Negative 3 take 5. So guys, here, what are you noticing here? The signs are what? The same. Once the signs are the same, guys, and we're adding our and subtracting, we must what? Add. So the signs are the same, so we must add the 2 numbers and keep the sign. That means we must keep a negative sign, a negative answer. So it means that 5 and 3 would be 8, right? And we keep the sign, so our answer is negative 8, and that's how we get our negative 8 here, guys. I hope that is clear, guys. I hope that is clear. Let's look at example D now. So this time we are subtracting B take A. Up here it was A take B, now it is B take A. So how do we set that out, guys? B take A equal to, we insert matrix, let me erase here. We insert matrix B, guys, which is that, subtract with our subtraction sign from the question, which is B take A, and then now we put our A over here. So guys, we have to follow the question, you know, exactly what the question tell us to do, that is what we're doing. So the question says B first, take away A. So we insert matrix B first, guys, follow what the question says, and then we take A from that, right? And now we move to the next step now, which is to show how we set out the elements now in carrying out this operation. So 2 and 4 correspond. So in this step, it would be 2 take 4, right? And for the other elements, it will be 5 take negative 3. So it is 5 take negative 3. So guys, let us do some rough work on that. So it is 2 take 4. So remember, guys, the 2 is a positive. What do you notice here? The signs are different. One is a plus, one is a minus. So it therefore means that we should subtract and keep the sign of the bigger. 2 from 4, we know that 2 from 4 is 2. And how do we know what sign our answer should have? We should keep the sign of the bigger absolute value. So it's a negative because 4 is the bigger absolute value, and the sign in front of 4 is a subtraction, it's a negative sign. So answer is negative 2, guys. So that's how we end up getting negative 2 here. Very good, very good. And now let us do the next one. 5 take negative 3. So we have 5 take a negative 3. So guys, 5 take negative 3. What are you noticing here? Before we can decide whether we add or subtract, we need to reduce these 2 signs here, guys, right? And sometimes it is written like this, you know, guys. Sometimes it is written as 5 take, and they use a bracket, negative 3. And this is actually correct way to write it, right? That means you're subtracting a negative 3 from 5. This is actually correct way to write it. But if you see it like this, guys, where the signs are just beside each other, like that without no bracket, it's the same procedure. So this negative and this negative here and this negative here would be deemed to be beside each other, guys. So it would still apply to a plus. So it still reduce it to a plus. So this is basically 5 plus 3. And we know that the 5 is a positive 5. The signs are the same, guys. So we're going to add and keep the sign. So that's 5 and 3 is 8. And the sign is a plus, so it's a positive 8. So that's how we end up with our answer, negative 2, 8. Okay, guys, I do hope that was clear. You can re-watch the video, and until it is clear for you. Okay, guys, but I would have broken it down as simple as I could for you. All right, guys. So before we Okay, so this is another example, guys. However, now we're adding 3 matrices now. So in this case, we have A plus B in bracket plus C, right? So A plus B plus C. So of course, according to the BODMAS or PEMDAS order of operation, right? PEMDAS parentheses or BODMAS, B there stands for bracket. So it means that we would do our brackets first, right? And then after our bracket, we'll do any indices and so forth and so forth. So because we're seeing brackets here, guys, according to our order of operation rule, PEMDAS or BODMAS, right? The P in PEMDAS actually means parentheses, and parentheses we know is bracket. BODMAS, B stands for bracket. So whichever one you use, guys, we must do bracket or parentheses first. So here we notice that A plus B is in bracket. So we must add A plus B first. And then when we get our answer, we add it to C. So that's how we are gonna do this, guys, when we're adding 3 matrices, right? We do what is in the bracket, and then after we get that answer, we add it to the other matrix that is to the left, to the right, sorry. In this case, it would be C. All right. So so let us set it out now. So A plus B. So we get a bigger bracket, right, to show that we are going to add these 2 matrices inside here. So we get a bigger bracket and we put in matrix A and matrix B, right? And then outside of the big bracket, we put our plus C, which is -1, 0. So let us work out what is in the bracket, right, guys? We would have worked that out previously, would have worked out A plus B previously, and we would have gotten the answer 6, 2, right? So we'd have added 4 with 2 and we get 6, right? So this is where we are now, right? So remember, all of this inside here works out to give us this right here, right? And so we put back this over here. All right, so we put back that matrix over there. So inside here works out to give us 6, 2. We did that previously, guys, so you can look back at that. So it was -3 plus 5, which gave us 2, right? So we subtract, keep the sign of the bigger value. So we get 2 here. So it is 6, 2, right? And then we're going to add that now to C, which is -1, 0. So to add that, guys, is the same procedure. It is 6 plus -1, 6 plus -1. So this plus and minus reduced to a minus. So it is basically 1 take 6, which is 5. Good. And so 2 plus 0, right, is 2. So this would be our answer, guys, right? So that is how you would add matrices in a case where it looks like this, right? So look at F. So for F, it is A plus B plus C. A plus B plus C all in bracket, B plus C all in bracket, right? So we do what is in the bracket first. So in setting out that, we put our matrix A first, right? Because that comes first according to what the question says. We put our plus sign, which is here, and then we put our big bracket, right? And then we insert B plus C, which is 2, 5 plus -1, 0. So we're gonna do this first, guys. We're gonna add in the bracket first. Now, when we add in the bracket first, we would have gotten 1, 5. 1, 5. See, 2 plus -1, guys. The plus and the minus would be beside each other, so it's an overall minus. So 1 from 2 is 1. That's how we get the 1 here. And where am I now? And 5 plus 0 would give us 5. So that's how we get that here. And of course, 4, -3 would be our A, which we are not ready yet to work on, right? We just put it back there, right? And do what was in the bracket first. So now that we have simplified this step, we now move to here. So we are now here, right? So what are we going to do here? We're going to add. That's the operation here. It says we're to add this matrix to this matrix. So if we're going to add this matrix to this matrix, it means that we're going to add corresponding elements. So it's going to be 4 plus 1, which is 4 plus 1, which gives us 5. And it means that for the other elements, it would be -3 plus 5, which would be this, which means that we're going to subtract because the signs are different. So we're going to subtract, keep the sign of the bigger absolute value. And when we do that, we get 2, right? 3 from 5 is 2, and 5 is the bigger absolute number here. So we keep the sign, which is a plus, so we get +2. So that's how we end up getting this here, guys. Okay, 5, 2. And so we move on to G, guys. Now we're subtracting. So it's kind of the same process, right? It's just that we're subtracting now. So of course we do what is in the bracket first, right? So we set it out, right? So we use a bigger bracket to put A, take B. So this is A, take B in our bigger bracket, and then we put our subtraction sign, right? And then we put C. So this is C, -1, 0. So we're going to work out what is in the bracket here, guys. Work out what is in the bracket here. We work out what is in the bracket, we're going to get 2, -8, right? See, 2 from 4 is 2. And -3, take 5, signs are the same. So we add and keep the sign -8. So that's how we get the 2, -8 here. And then we put back our C, which is -1, 0. So now this is where we're at now, guys. So what we're doing here, we're subtracting. That's the operation between the two matrices. We're subtracting these two matrices. So if we're subtracting the matrices, it means that we're subtracting corresponding elements. So let us subtract 2. So 2 and -1. So it would be 2 take -1. 2 take -1. So these two signs are here beside each other. It's going to become a, reduce it to a plus. So it's basically 2 plus 1 give us 3. That's how we get that 3 there. And then we have -8 take 0, right? We know that 0 has no value right now. So it means that we'd only be left with, so taking, so here, if we should add and keep the sign, this would be basically a -8, right? So that's how we get that. All right, guys. And it's the same procedure for here, for H, right? However, we're going to do what is in the bracket first, which is B take C. So we do what is in the bracket first. So we set it out. We put our B here, right, which is 2, 5, and our C here, which is -1, 0. We subtract, right, these two matrices here, right? 2 take -1. So these two signs here would become a plus if we should, you know, work it out rough, right? And so we would get our 3, which is right here. And 5 take 0, we would get back our 5 here. So that's how we would reduce what is in the bracket to 5, 3. And then of course, our A would come back here, right? Because we're not troubling it yet. So we put it back there, right? We work out what is in the bracket first to get this, right? And now that we get our result, we can now go ahead and subtract. So we're now at this step, right? So let me erase some of this. So now we're at this step, guys. So to subtract again, it is 4 take 3, and we know that the 4 is a positive, so the signs will be different. So we subtract, keep the sign at the big absolute value. So we get our 1 there, and the -3 take 5. The signs are the same here. So it means that we're going to add and keep the sign, right? So that's how we get our -8. So guys, that is pretty much how we add. This is an extensive, thorough breakdown of our addition and subtraction of matrices, guys. All right. Now, before we continue, we're going to go back to a concept that I said we would have come back to. And when you're doing addition and subtraction of matrices for CSEC, guys, you must understand that the syllabus requires that you understand commutative and associative property of addition and subtraction of matrices. Commutative, guys, also known as commutativity or commutative, and associative or associativity. Just using different part of speech, guys. So commutative or commutativity and associative or associativity, right? And of course, if an operation is not commutative, then it means that it would be non-commutative. So if an operation is not commutative, guys, the opposite would be non-commutative or not commutative, right? Or non-commutativity. So the opposite of commutative is non-commutative or not commutative, right? And if an operation is not associative, then it would be non-associative or not associative. Okay, guys? So I hope you get those clear. Now, let us look at what this commutative and associative thing is about. So first, let us look at addition and let us look at the commutative property. Now, before I apply the commutative property to addition of matrices. Let us first draw back our attention or our memory to the real number world, right? So in the real number world, guys, we're just focusing on numbers, negative and positive numbers, right? Remember, or you should have done these properties before when you were looking at numbers, probably in grade 6 and 7 or 8. At the least, you should have done these properties. So this is what you should have learned at that time. Just a little synopsis of it. So the commutative property of addition. So we're looking at addition. So we want to find out if addition is commutative in the real number world. So to find out if addition is commutative, it is basically saying if you add 2 plus 1 or 1 plus 2, would you get the same answer? So that's what the commutative property is all about for addition. So if you add 2 plus 1 or 1 plus 2, would you get the same answer? If you get the same answer, it means that addition is commutative. So for the commutative property, all you're doing is switching the things around. Switching the things around the operation. So the operation is addition, you know. So you're switching the numbers about the operation. So in this instance, right, the 2 is in front of the operation. And in this instance, the 2 is behind and the 1 comes at the front. In this instance, the 1 was behind. So for the commutative property, guys, you are interchanging, you're switching around the elements, you're interchanging them. And if having interchanged them and carry out the operation, you get the same result, it means that that operation is commutative. All right, so let us check it now. So we have 2 plus 1. Is 2 plus 1 the same as 1 plus 2? Well, let us see. 2 plus 1 is what? 3, right? And 1 plus 2 is what? 3. So it means that they are equal. So it means that addition is commutative in the real number world, right? Let us check commutativity for subtraction. So commutativity now for subtraction. So, and we normally prove this using 2 numbers, guys. We don't need 3, 4, 5 numbers. We use 2 numbers, right? So 2 take 1. Is 2 take 1 the same as 1 take 2? Let us see. 1 from 2 is what? 1 from 2 is 1. And 2 from 1 is -1. So clearly we can see that subtraction is not commutative or non-commutative, right? So if the 2 things are not equal, having interchanged the numbers, right? If they turn out not to be equal, it means that this operation that we're carrying out, subtraction, would not be commutative. So it would be non-commutative, right? So subtraction of real numbers is non-commutative, right? That's in the real number world, right? So let us now come back to the matrix world now. So the matrix world, if we have a matrix A, right, and we add it to another matrix B, right, would we get the same answer as if we had B plus A? So that's all we are trying to prove, you know, guys. So this is now asking if addition of matrices is commutative. Do you think addition of matrices is commutative, guys? That means if we have 2 matrices, right, and one of them is A and one is B, and we said A plus B, right, and we add A plus B and we get an answer. And then in another instance, we add B plus A. So we put B at the front, right? In this case, A is at the front. In this case, B is at the front. In this case, B is last. In this case, A is last. So if we interchange the matrix, right, and add them, would we get the same answer? If we get the same answer, it means that addition of matrices would be commutative. And if we don't get the same answer, it means that it would be non-commutative. So that's all it is saying, guys. It's a form of proof, right? And once we can prove if the two things are the same, having interchanged them about the sign or about the operation, and we get the same answer, it means that it will be commutative. And if we're not getting the same answer, it will be non-commutative. Is that clear, guys? So let us check. So in this example that I went through previously, right? Here we have A plus B, right? And when we add A plus B, we got 6, 2, right? You saw the working out, we went through it. And now here we have another example where we're now adding B plus A. So in this case, it was A plus B. And now we interchange the matrix now. We put B at the front. In this case, it was A at the front. And so now that we interchange the matrix and carry out the addition operation on both of them, what are our answers? Our answers are the same. So it therefore means that we would have proven that addition of matrices is commutative. So addition of matrices is commutative. That means if one person should add A plus B and another add B plus A, they would get the same answer. And that is due to the property of commutativity of matrices. The property of commutativity of addition of matrices is basically saying if you're adding two matrices and you add this one to the next, you'll get the same answer as if you add the last one first to the first one, right? Pretty much. Okay, guys? So you would have seen here that the answers are the same, right? Having interchanged the matrix, right? It therefore means that addition is commutative. However, let us look at C and D now, subtraction. So let's see if subtraction is commutative or not. So here we take B from A. So B from A give us 2, -8, and A from B gave us -2, 8. Right, guys? So you can see here that these two things are not the same. So after we interchange the matrix, now we are carrying out a different operation. We're now subtracting. But after we interchange the matrix, right, in both cases, we realize that we are not getting the same answer. So that is why it is a proof that subtraction is non-commutative. So subtraction of matrices is non-commutative, guys. So please bear that in mind. All right. All right, now let us look at now the next property, guys, which is associativity, right? So let us explain that with the real number world again. So the real number world, guys. Now, first of all, I need to know that for the associative property to be proven, you have to use at least 3 things. 3. We cannot associate 2 things. We have to associate 3 or more. So to prove associativity, we're going to be using 3 numbers, right, guys? We cannot use 2 numbers or 2 things or 2 items to prove associativity property of addition or subtraction. We have to use 3 numbers or elements or items, right? So let us now explain this using the real number world before we apply it to the matrix world. So associativity. So if I have, so remember we're looking at the associative property now for addition and subtraction. So if I have 2 plus 1 plus 3, all right, guys, so I have my 3 numbers here and I'm adding all 3. Now we need to associate them now. So to associate means that we're going to group the first 2 numbers. So to group them means that we put them in a bracket. So we put the first 2 in a bracket, right? And work it out. So once you put in the bracket, it means that you are now associating elements now. So you're grouping elements. You're grouping. So we group the first 2, right? And then we're going to work this out now. So when we work this out, because we group the first 2 numbers, right? We must do what is in the bracket. So 2 plus 1 is 3, right? And we put back our plus 3. So we end up getting 6, right? Now, on the other hand, now, the next proof of this is we must have the same three numbers, 2 plus 1 plus 3. However, we're going to associate them a different way now. So in the first instance, which is this, we associate the first two numbers, right? So now, in this next proof, we must associate the last two. So we're going to associate the last two, right? And if these two things, if these two problems turn out to be equal, having associate the first two numbers in this instance and the last two in this instance and carry out the operation, if we're getting the same answers, it means that addition would be associative. So how do you do associative, guys? Three numbers, group the first two, work it out. Use back those three numbers, group the last two, work it out. And if you get the same result, it means that addition is associative in the real number world, okay? So let us work out in the bracket. 3 and 1 is 4 plus, put back our 2. 2 and 4 is 6. So guys, what are you noticing? We get the same answer. So it therefore means that addition would be associative in the real number world. Everybody see that? Very good. So let us now do it for subtraction. So subtraction, we're using the same numbers, however, changing the operation now, subtraction. So we're using the same numbers, right? And let me write back up here and show you how we prove this in the real number world now, guys. We haven't started doing it for matrix yet. We're just recapping your knowledge of the property of the associative property of subtraction and addition. All right. So now we're looking at subtraction in the real number world. So we're going to group the first two, and we're going to group the last two. Right? So let's work out what is in the bracket in this first problem here. So 1 from 2 is 1. Take 3. 3 from 1 is -2. Right, guys? Because remember, this is a +1. The signs are different, so we subtract, keep the sign of the bigger. All right? So we get -2. Let us do the next one up here now. Because remember, I know these are the two things we're associating, you know, guys. We're associating the first group. We associate these two numbers here, right? So we have to use 3 numbers at a time, right? So we associate the first one, now we associate the last 2 numbers up here. Now we're going to work it out and see if we get the same thing. So put back our 2, take 3 from 1. 3 from 1 is -2, right, guys? And the signs are beside each other, so that becomes a plus. So we end up getting what here? 4. So what do you notice? Our answers are not the same. So this can tell us that subtraction is not associative in the real number world. So in the real number world, subtraction is not associative. However, addition is associative. Okay, guys? So that's just a synopsis, a recap of the associative property in the real number world. So we would say that these are not equal. So subtraction would not be associative. Okay, guys? Because we're not getting the same answer. We're getting -2 and we're getting 4. We're getting -2 and we're getting 4. So it means that these two things are not equal. So subtraction is not associative in the real number world. So let us now see what it is in the matrix world. Okay, guys, I know the video is a little bit long, but I want to cover these concepts under addition and subtraction. So now let us quickly prove the associative property now. Now here, it is telling us that subtraction of matrices is non-commutative. So it is telling us, right? However, we're gonna show you the proof on the other slide. And it is also saying that subtraction is non-associative. Okay, we did commutative already, so I should be focusing on these two, right? So addition, it is telling us that addition is associative, right? And it is telling us that subtraction is non-associative. So let us prove that over here now. Where is that? Over here. Good. So let us prove addition. So these two is looking at addition, and these last two is looking at subtraction, right? So let me clear this. So we're going to look at these two, which is the addition now. So we're looking now, guys, to see if addition of matrices is associative. So remember, to prove associativity property, guys, we have to use 3 matrix, 3. So remember, we had the C matrix. So now, so we write down our A plus B plus C, and then we put a bracket around the first 2. So remember, that's how we do it, guys. So we have the 3 matrix, put addition between them, among them, and then we put a bracket on the first 2. So we bracket the first 2, right? And then we're going to work this out. And then for the second part, we bracket the last 2 matrix and then work that out. And if we get the same result, it means that associativity would be true for addition. So we bracket the first and we work it out. Remember, we did this before, guys, went through it. So when we add that and that and that, we get our 5 negative 2. And then when we do this one, right, when we add B and C first and then add it to A, right, we get 5, 2. So the answers are the same. So it therefore means that addition would be associative. And that is why we have this statement down here. This is the same as this, right? They're equal. And if you can prove that, guys, with any matrix, it doesn't have to be these that I have here. It could be any matrix you're adding or subtracting. Once you have 3, you can prove this property, guys. Let us go to the last property here, which is subtracting or proving subtraction, proving if subtraction of matrices is associative. So again, guys, we write down the 3 matrix, right? Put the subtraction sign between them and we group the first 2. So when we group the first 2, we work it out first, right? And we get this, and then we subtract it from C, which is this, and we show it there, and we got that as our answer, 3, negative 8. And now we must prove the next part, which is the 3 matrix, subtraction sign between them, and we group the last 2, and then, because we group the last 2, we work that out first, so we work out this first, and we get this, and then we put back our A, which is here, and then we subtract, and we get this. Now, are these two matrices the same? No, they're not the same. So it therefore means that subtraction of matrices is non-associative. And that is how we write it, guys. They're not equal. This and this is not the same. See, the results are different. One is 3, negative 8, and one is 1, negative 8. So they're not the same. So this can prove, in general now, this is general, guys, this is facts, that subtraction of matrices is non-associative. However, addition of matrices is associative. Okay, guys? And so that is how we end up with these facts around here, that addition of matrices is commutative as well as associative. Oh my. As well as associative. And subtraction of matrices, right, is non-commutative and non-associative. So if you're asked to prove that, guys, this is how you would do it, right? Remember, for the commutative, you interchange the things, right? When you're doing it for addition, you interchange, put the addition sign. When you're doing it for subtraction, you interchange, put the subtraction sign, and you can prove that way, guys. And for associative, it's the same process. However, you use 3 matrix, right? And you group the first 2, group the last 2, work them out, see if the answers are the same. If the answers are the same, it means that it's associative. If they're not the same, it means that it is non-associative, whichever operation it is. Okay, guys? So what you need to learn from this is that addition of matrices is commutative and associative. Subtraction of matrices is non-commutative and non-associative, right? If you have any difficulty with these facts, guys, you can rewatch the video and see how I went about proving these facts right here. Okay, guys, so that's it for the commutative and associative property of addition and subtraction of matrices, guys. Right? We went through it thoroughly, and I hope you would have learned something from what we did. Okay. All right, now we are wrapping up, guys. So basically, we have some work examples here, right? Just some further examples, guys, some further working out of addition and subtraction of matrices, right? You can pause the video and look at these working out, guys. They were done for you following the same method that we looked at previously in adding and subtracting the matrix, guys. Let me just run through this number one here for you. So here we're adding matrix, this matrix here and this matrix here, matrix 1 and matrix 2. Are they of the same size or order? Yes. Matrix 1 is a 2 by 2, matrix 2 is a 2 by 2. So they are compatible, right? And because they're compatible, we can go ahead and add them. And when we're adding them, we add corresponding elements, right? So this example did not show you the second step, just goes right to the answer, right? Because they did it mentally. However, let me just go through it for you and show you. So here we know that 10 and -6 correspond. So we'd set it out on our rough sheet as -10, right? Plus, put our plus symbol that is between the two matrix and our -6. So guys, what do we notice here? We notice that a plus and a minus is beside each other. So reduce that to a minus. So we end up with what? -10 take 6. So what do we see here? The signs are the same, guys. So we're going to add and keep this sign. Oh, sorry. My bad. It's not a negative. It's not a -10. It's a +10. It's a negative. It's a +10. So sorry. So it's a +10 plus a -6, right? So a plus and a minus beside each other becomes a negative. So that is 10, right? 10 takes 6. So 6 from 10 is 4. So that's how they get the 4 right there. Okay, guys? Now the next one is 0 plus 3. So 0 plus 3, that's 3, right? And -4, so that's -4 plus 1, guys. Signs are different, so we're going to subtract and keep the sign of the bigger. So that's going to be 1 from 4 is 3, so that's going to be a -3. That's how they get that -3 there. Then we're going to what? Add 5. Add 5 with -7. So that's going to be 5 plus -7. So again, guys, we reduce the sign here, two signs beside each other. We must reduce it before we go ahead and perform an operation. So that's going to be 5 take 7. So we're taking 7 from 5. Remember, this is a +5. So the signs are different. So we subtract, keep the sign of the bigger absolute value. So 5 from 7 is 2, and the sign in front, the bigger number is negative. So it's a -2. That's how we get that here. Okay, guys. So it's the same process that we did the ones previously, guys. Right? And you can do this one. And I'm just going to run through this one for you. It has a little bit of algebra in it, right? But it's the same procedure, guys, the same procedure. All right, so here we're adding 2 matrix here. Matrix 1, matrix 2. These matrix don't have a name, guys, like these ones over here. These have a name. This is matrix A, this is matrix B, right? However, these don't have any name. Remember, guys, a matrix doesn't have to have a name, right? So if it doesn't have a name, once we represent it in matrix form, we can go ahead and perform the operation because it's a matrix, just that we didn't give it a name, right? So these ones don't have any name. However, it is telling us what to do, where to add them, right? So we're to add these two. So are they compatible? Yes, this is a 2 by 1 matrix, and this is also a 2 by 1. So this is a 2 by 1, and this is also a 2 by 1. Oh my. This is also a 2 by. Oh my. Hold on, guys. Thing is on here. Right, so that's a 2 by 1. So it's a 2 by 1. So they're compatible, right? So we are going to go ahead and we're going to add corresponding elements. So -6m is corresponding to -3m, right? So we're going to set that out as -6m plus, there's the plus right here, guys, the plus between the two matrix, take 3m. And just like when we were doing with real numbers, guys, not because the letter is there, remember in algebra, if the letters are the same, right? Exactly the same, right? This is m and this is m, right? Not m and m square are not like, but this is m and this is m, so they're like terms. So we can add them just like we would add our subtract normal numbers. So, but we reduce these two signs here, guys, to a minus. So it becomes -6m take 3m. So it is -6m take 3m. So we would do this just like it was -6 take 3. And if it were -6 Take 3 would add and keep the sign, guys. So it would be -9. However, because it is algebra and the letter is there, we have to put back the letter. So so basically we do this just like we were doing normal numbers. We're adding and subtracting normal numbers. So this would give us -9. However, this one up here, we put back the m, so it would give us -9m. Okay, guys. So if it confuses you with the letters, right? Just remember that these letters are like terms, and in algebra we can add or subtract like terms. However, if you want to picture it without the letters, right, guys, this is how you would picture it, right? And you'll get a -9. And all you do is just put back the m, okay? So it is -9m. So that is how we get the -9m here. Very good, very good. Let's do the other elements now. So it's -2n plus 5. Now, guys, -2n plus 5. Can this be simplified any further? No, because -2n and 5 are unlike terms. This is -2n and this is 5. If this had an n on it, if this was 5n, we could have go ahead and perform an operation and simplify it. But guys, this can't go any further because, as you can see there, there are 2 unlike terms. So we have to leave it as -2n plus 5. And that is how we end up with -2n plus 5. We have to leave it like that. So guys, that is how you would have done this. So the principle remains the same, guys, just that it involves subalgebra. So make sure algebra skill is good, because remember, you're doing mathematics. Once you're doing math, guys, you will encounter algebra, okay? So that is just mixing some algebra into matrix, guys. But the concept remains the same. The concept of addition and subtraction of matrices remain the same. It's just for you now to sort out your algebraic skills and apply them, okay, guys? And so you can pause the video and do question 2, question 4, and question 5, you know, and see if you get these answers that are there. And now I have a activity for you now, which is this activity here, right, for you to do. So it's just an activity that, you know, encompasses most of what we did on this topic here. Okay, guys, so you can pause the video and complete this activity. You can leave the comments below. You can, you know, go in the comment section, work them out, and show me your answer, show me your working out if you want to, right, guys? Or you can check the video for my email and you can work out your solution and email it to me, guys, and I will check it and see if you're correct. Okay, so pause the video, take down this activity, guys, work them out, and you can leave your answers in the comment, or you can email me and send me your response, guys, and I will surely respond to you. Okay, so this is the end, guys, of matrices part 2, where we looked at addition and subtraction of matrices. Thank you so much for watching, and please to like and subscribe to this channel, because we will be posting part 3 next. And part 3, we will be looking at scalar multiplication and the matrix by matrix multiplication, guys. So that would be part 3. Thank you so much for watching, and I do hope you enjoyed this video. Please remember to subscribe to the channel, so so when I post other videos, you will be notified as well. Thank you so much, guys. Take care.